This map is lying to you right now. On most world maps, Greenland looks almost as big as Africa, but in reality, it isn't even close. Your brain has been trained to accept a distortion as normal, and once you see it, you'll never look at a map the same way again. Here's the weird part. If you look at Greenland from space, it's definitely big. It's just nowhere near the size your brain thinks it is. The mistake isn't geography. The mistake is what happens when humans try to flatten a sphere into a rectangle. For centuries, mapmakers faced an impossible problem. The Earth is round, but every map we hold is flat. And when you force a curved planet onto a flat sheet, something has to stretch. The question is, what stretches and where? On many common projections, land near the equator looks pretty normal. But as you move toward the poles, the map starts inflating area, like a rubber sheet being pulled outward. That's why places like Greenland, Alaska, and northern Russia swell on paper. That's why Greenland looks gigantic. Africa is actually more than 14 times larger, yet on a lot of classroom maps, they look almost equal. Your eyes trust what they see, even when it's mathematically distorted. And once that distortion becomes familiar, it starts to feel like truth. The projection most people recognize is called Mercator. It was designed for navigation. Sailors needed straight lines, so a compass heading on the map would match a real heading on the ocean. Mercator delivers that beautifully, but it pays for it by stretching everything near the top and bottom. Think of it like this. On a globe, lines of latitude get smaller as you move toward the poles. But on Mercator, those lines are forced to stay the same width. So the map has to add space. And it does it by inflating the areas you see in high latitudes. That hidden inflation changes how the world feels. If Greenland really looked the way the map suggests, the Arctic would dominate the planet. Europe would feel massive. Canada would feel endless. And equatorial continents, where most people live, quietly shrink in comparison. Now watch what happens when we do a simple trick. Keep the same map projection and just drag Greenland downward toward the equator. The land itself doesn't change, only its position on the grid. And suddenly, Greenland shrinks dramatically. That one movement exposes the distortion. This is where most people pause, because the map you're trusted your entire life starts to feel unstable. If Greenland can shrink just by moving it south, what else has been quietly stretched? What else have you been trained to misread without even noticing? So here's the trade. Mercator preserves angles, which is perfect for navigation. But it cannot preserve area. And when people see a map every day, on walls, in textbooks, on screens, they stop seeing it as a tool. They see it as reality. Let's make the illusion even clearer. Imagine a strip of the Earth right at the equator. It's wide. But now imagine a strip near the Arctic. On the real planet, that strip is much narrower. Mercator forces both strips to be the same width on the paper, so the map compensates by stretching the land. The closer you get to the poles, the more stretching you need. That's why Greenland balloons. It's why Antarctica becomes a giant white wall. It's why northern countries look bigger than your intuition expects. And this isn't just trivia. Maps shape your mental model of power, importance, and distance. When one region is drawn larger, it feels larger. When another is drawn smaller, it feels less significant, even if the opposite is true in real area. Now, to be fair, no flat map can be perfect. If you protect shapes, you sacrifice areas. If you protect areas, you sacrifice shapes. If you protect distances, directions bend. Every projection is a choice about what you're willing to lie about.